Hi there folks, thanks so much for joining me for this discussion on local development in serverless. And thanks so much to our hosts. If we were all gathered together, I would ask us to give them a round of applause for all their hard work. So feel free to drop your thanks to them in chat if you can instead. And now that we are in the new year, it's already February. I have no idea how that snuck up so quick. It seems as if there has been a lot of renewed interest in tools and methods that can make development faster and more productive, serverless amongst them. And a question I hear all the time and see all over the place is from folks trying to figure out how to apply the principles of local offline development when building serverless applications. That's what today's talk is all about, as I'm sure you've gathered from the title. And to get us started and set some context, let's take a quick look at what we mean by local development and where we have come from. Traditionally, I am sure most of us are aware that when building things for the web, these apps sit on big, chunky machines with great fat pipes, often multiple of them for redundancy and load sharing. And some, including myself in the early days, would often just edit our relatively simple scripts and apps directly on these machines. That very quickly changed as apps became a lot more complex and reliability was needed. It's nothing more unreliable than typos on a production server. So this is where engineers and teams had to find a way to develop their applications on their local machines. And usually this was just running an Apache web server on your own laptop and calling localhost in the browser to test. Over time, we have evolved these techniques by switching to virtual machines and more recently containers to help bundle these environments to be shareable. We've also realized that a developer's local machine will never be as accurate a representation of the data center the application is served in. So teams often have created replicas of their production infrastructure purely just to do integration testing with all the other moving parts. This has obviously helped a lot by the advent of the cloud and the ease with which infrastructure can be added, removed, and deleted. I'm skipping past quite a bit, but I think that's enough context. All of this leads up to today, where we now have teams looking to build solutions in a serverless way that dispenses with those servers and replaces them with managed services like API Gateway, Lambda, DynamoDB, and more. But we still want to bring the idea of developing locally with us. Let's dive right in then and start looking at what our options for local development look like. And the first of these is built right into the serverless framework, serverless invoke local. Using this command, you can quite easily have your code in your Lambda function executed and see the result. In this example, we have a very simple Lambda function, and running invoke local on the function name executes that code and shows us the output. But most Lambda functions will want to use some form of input to process upon. So let's tweak our function to process an incoming event object. And then let's create a quick data file. And now we can pass that data file to the invoke local command. There are some problems with this process, of course. As you can see, we have added a call to a DynamoDB table in this function, and I'm sure you can all see what happens next if I locally invoke the Lambda function. An error, of course, since that table does not exist, nor does a connection to AWS even exist. So while the invoke local command is great for a built-in way to quickly execute some code, using this exclusively is tricky, especially when you need to talk to other services in your AWS account. It's no secret that serverless is awesome at APIs. There are countless demos of how to easily and quickly configure a REST API using the serverless framework. I've made a few myself, and I'm sure many of you have done it as well. And just like in the past, the way to test a REST API is to spin up an HTTP server so we can send test API requests to these endpoints and look at the results. How do we do this in serverless? Thankfully, it's pretty simple. The serverless framework provides a pretty powerful plugins architecture. And one of the most popular of these plugins is one called Serverless Offline. All it really does is read your configuration, grabs all the functions with HTTP events attached, and creates endpoints to them with a local web server. Run a command on the CLI to get it rolling, and it also feeds you logs from your functions. Pretty nifty. While this tool is very popular for teams developing REST APIs, that's really all it's good at. And this means that if you're looking to put together a bunch of functions triggered by other events such as S3, DynamoDB, SQS, SNS, or countless others provided by AWS or other cloud providers, you're out of luck. Inevitably, what the limitation means is that applications that would be better constructed using the breadth and depth of services available to them and the associated Lambda event triggers just aren't, because you cannot test it locally with this tool, and that's a shame. Not to mention that your Lambda function still might have code that is trying to speak to AWS services and erroring out instead. This is where LocalStack comes in. LocalStack is a pretty impressive project aimed at making it easier to emulate running a variety of AWS services locally. Combine that with a pretty well-maintained plugin for the serverless framework, and this looks like a compelling tool to use for local serverless development. It works by intercepting requests on your local machine to AWS services over the AWS SDK and routing them to services running on your laptop. Services such as Lambda, S3, IAM, DynamoDB, SNS, SQS, and a load more, as you can see here. However, it may be apparent to you that that looks like a lot. And that's one of the biggest downsides of LocalStack. It's a lot to have running on a machine, as well as a lot of added complexity to get things running on a developer's machine. It also requires some additional configuration that is specific only to local development. So you'll be forced to deploy code that really only matters locally, but is now pushed to Lambda anyway. It also still suffers from the issues around Serverless Offline. If there is an AWS service you want to use that is not currently supported by LocalStack, you either build it anyway with no local testing, kind of defeating the purpose, or you hamstring your application while waiting for support to be added, if it ever is. Another method that has had some popularity ignores the cloud altogether and combines unit testing tools such as Mocha or Jest to execute Lambda function code locally, and deals with any AWS services used by the Lambda by mocking them out instead. This is a lot easier to set up than you might think as well. Again, with the power of serverless framework plugins, there is a Mocha and Jest plugin we can use to help us put this integration together. Combine it with the AWS SDK mock node module, and it becomes rather trivial to create these. And time consuming. While this method was my own choice for quite a while and has the benefit of being pretty light on your machine, since you don't have a dozen or more emulated AWS services running locally, and being pretty quick to execute, writing the tests themselves, and especially the mocks, end up being impressively time consuming. And as we shall see later, this still suffers from the issues all of these offline methods do. No amount of effort made trying to set up a complete local testing environment will ever be really as accurate as it needs to be. Even with a tool as impressive as LocalStack, it's just not the same as when your serverless service is actually deployed across an AWS account and running in the cloud. First of all, Lambda functions have a bad habit of being amazingly ethereal. As soon as the execution of the main thread completes, the entire execution of that Lambda halts, even if there are other items still to be processed in the call stack. An example looks something like this. And while running locally, everything looks great. In the Lambda environment, that promise may or may not ever complete, since Lambda will cease execution as soon as the main handler returns. What's even worse is that the call stack may finish execution when the next Lambda invocation comes in as well. So you end up in a situation where bits and pieces of code you were hoping would execute when the Lambda was originally invoked sometimes do and sometimes don't, and sometimes only after another invocation of a Lambda. You can't test this locally. Another example is IAM. IAM permissions can bite you in any number of ways, and you can only really determine the true impact of what IAM will do to your carefully crafted service when running within the AWS environment. Ultimately, you want to put together IAM permissions for the services and functions that limit the scope exposed to them, but it's impossible to test whether these restricted permissions are too limited if you're testing locally. Not to mention, there is also the impact of just being remote in the cloud and combining multiple services together that need to communicate over networks. Fast networks, sure, but there is added latencies. And AWS services also have limits associated with them. If you have a runaway number of invocations locally that shove millions of messages per second into your local version of SQS that could hit limits in the cloud, you wouldn't ever notice locally. The alternative to all the methods we have discussed up till now is to not use any of them. Sure, you could cobble together something that sort of resembles AWS on your machine to allow you to test a function locally to a certain level of confidence. But all that local testing gets you is slightly increased turnaround time from change to code and testing, and being able to develop offline. Maybe. But being online is no longer the issue it used to be. Sure, if you wanted to hack away in that cabin in the woods for a few weeks, you may have a problem. But these days, even the cabin in the woods can get near fiber quality internet access to upload the kilobyte-sized zip files that serverless services generate most of the time. And there are specific techniques that can greatly decrease the downtime from pushing changes to the cloud. Firstly, when you run a serverless deploy command, it takes some time, but this command is only really needed when you have infrastructure changes that need to be deployed. In other words, adding new endpoints to API Gateway, new Lambda functions, IAM changes, adding additional resources such as DynamoDB tables. It's not needed if all you have done is edit some code. Instead, you can use the much faster serverless deploy function command that will only push an update to that specific Lambda function's code, and within seconds, you're ready to test again and continue iterating. But Gareth, I hear you say, if I'm deploying into AWS and my team members are deploying into AWS, aren't we just going to be overwriting each other all the time? This is where an awesome service from AWS comes into the picture, Organizations. It allows you to add additional AWS accounts under a parent AWS account and give access to them to individual team members. So now you can make sure that every developer on the team is entirely isolated from every other developer and won't accidentally deploy to any shared staging environments or, heavens forbid, production. And when deploying code into a shared environment, what we really need is a tool that can help manage code from multiple team members and merge the differences together with no conflicts. Something just like your GitHub repo. And using CI/CD triggered off of GitHub PR mergers to deploy into these environments means you can quite easily and quickly test the integration of the service you've been experimenting with in your own AWS account with all the other services the rest of the team has been working on. At Serverless Inc., we provide a tool to help you manage CI/CD and a bunch of other stuff. So if you need an easy way to set this up, head over to app.serverless.com, which also supports Bitbucket as a Git repo, by the way. Now that you have a way to get all the bits and pieces together from your entire team, this means you can now run integration tests across all the services before deploying to production. So we've gone through all of this and talked about what looks like the best way to develop locally. Let's close the loop a little and combine this with what the idealized software development lifecycle looks like. Obviously, starting from local, each developer has their own AWS account provisioned via AWS Organizations, using the serverless framework to deploy code changes and eventually be able to publish a feature branch into our Git repo. Our team also has a CI/CD configuration to deploy all PRs created against our develop branch to be automatically deployed to a shared AWS account. So I, as a developer, go ahead and push my changes and create my pull request to be merged into develop. Now, when my coworker needs to review my work, not only can they look at the code as usual and LGTM, they can also test my service in AWS itself. My pull request is accepted and the code is merged. The PR is deleted as well as the review deployment, and now my change triggers a deployment into the development environment. It's at this point I can kick off my integration tests if I wish to validate that my changes do not break functionality across all the other services. Since pretty much the entire process is automated, this leaves very little space for human error. And because we are always testing within AWS instead of some emulated environment, we can be sure that when it gets to production, things should continue to work as intended. I'd like to finish off by showing off a little bit. At Serverless, we have been developing directly in the cloud for a while now. Everything I've described is essentially our modus operandi. And all the techniques I've discussed for trying out local development, I've tried myself as well. And while we wholeheartedly recommend developing in the cloud, we agree it's a little janky. So over the last few months, we have been working to try and improve this, and this is where Serverless Desktop comes along. Serverless Desktop is designed to be a tool to assist you in developing your serverless applications. And right now it's very much in beta. We are looking for folks to try it out, take it for a spin and let us know what they think. If it's useful, what they would like to see. This is a tool for serverless developers. Right now, what Serverless Desktop lets you do is synchronize all the existing CloudFormation stacks from your AWS account automatically, not just Serverless Framework ones. Then be able to invoke that Lambda function directly from your local machine, passing any event object you want, or using the included event trigger, which right now is only for API Gateway. The logs from these invocations are also then streamed live to you to allow for you to debug. You can also quite handily save those events or queries you send as tests for reuse later. But one feature I really find useful is the ability to turn on hot reload, a dev mode if you will. Point desktop at the folder of the service on your local machine, and as you edit code in one window and save the function, desktop automatically pushes those changes to AWS for you. And now you can reuse that test query you saved previously, make another change, save, auto deploy, test. A nice quick iteration loop. Bundled with this is also the ability to work with DynamoDB and S3. So if you have a DynamoDB table you would like to query to check for specific data that may or may not have been saved, make some edits to for testing, it's all available right here. Serverless Desktop is available right now for anyone to try out. Just go to github.com/serverless/desktop and download the binary. It only supports macOS for now and Node runtimes, but other alternatives will be coming very soon. And let us know what you think and how you get on with it. We really want to make this a useful tool for teams and need that feedback. In conclusion, I feel like I've gone through a lot, so thank you so much for taking the time out of your day to listen to me waffle on. If anyone wants to get in touch with me, you can easily do so by sending me an email at gareth@serverless.com, or if it's easier, just message me on Twitter at GarethMCC. I love talking to folks about serverless. And now I believe we are over to some questions, so please fire away.